5.1 Work. Work is the dot-color product of the force and displacement. Work is also product of the component of force parallel to the displacement times the magnitude of displacement. What is Joule? 1 Joule is a work done by a force of 1 Newton which displaces the object for 1 meter in the direction of the force.
First of all, work done by a horizontal force F or an object. A constant force F is in the same direction as the displacement. So if the displacement goes to the right, so the force also be the same. W equals to F cos theta, where theta equals to 0 degree. It means that W equals to Fs. The next one is work done by a vertical force F weight W or normal force N of an object. A constant force F is in the perpendicular to the displacement. W equals to F cos theta, where theta equals to 90 degrees or 270 degrees. W equals to 0 joule. The third one is work done by a friction force at small f on an object. The constant force F is in the opposite direction to the displacement S. W equals to Fs cos theta, where theta equals to 180 degrees. W is equals to negative Fs.
Number 4. Work done by a force F and frictional force on an object or work done to move the object. A net constant force F is in the opposite direction to the displacement. The formula for number 4 is W equal to negative F net S. Number 5. Work done by horizontal forces F1 and F2 on an object or work done to move the object. A constant force F is in the same direction as the displacement. The formula is W equal to F net S. Number 6a. Work done by a force F at the angle on the object. A constant force F is at angle to the displacement. W equal to Fs cos delta. Then number 6b. If more than one force acts on an object, the total work or net work is the sum of the work done by each force separately. The formula is W net equal to F net S.
Now I will explain about example 5.1.1. A box of mass 20 kg is pulled by a horizontal force F of magnitude 250 Newton along the horizontal plane. The coefficient of kinetic friction between the box and the plane is 0.300. If the box travels 3.80 meters along the plane, determine A. the work done on the box by the force F, B. the work done on the box by the gravitational force, C. the work done on the box by the reaction force, D. the work done on the box by the frictional force, E. the total work done on the box. From the question, mass M is 20 kg, force F is 250 Newton, S displacement is 3.80 meters and mu K is 0.300 and acceleration or G is equals to 9.81 ms negative 2. Question A. The work done on the box by the force F. So from the formula, W equals question D. The work done on the box by the frictional force. From the diagram given, F to S is 180 degree, and that's why the theta is 180 degree. From the formula W equals to F as cos theta, where cos theta is equals to -1, and hence that's why the new formula is W equals to negative Fs. Now we need to find the Fn. Fn is equals to mg, where the m is 20 and multiply g 9.81, and the answer for n is equals to 196.2 Newton. Next, we need to find the frictional force. The frictional force formula is mu k multiply Fn, where mu k is 0.300 multiply Fn 196.2, and the answer for frictional force is 58.86 Newton. So from the formula W equals to negative Fs, where F is frictional force 58.86 multiply S 3.80, and the answer will be negative 223.668 joule. Question E. The total work done on the box. So the formula of W net is WF1 plus WF2 plus Wn plus WF frictional force plus WW. What we have found is WF plus WG plus Wn plus WF for frictional force. So it is equal to 950 plus 0 plus 0 plus negative 223.668. And the answer will be 726.332 joule.
So this is example 5.1.2. A force F acting on a particle varies with the displacement x as shown in figure below. Calculate the work done by the force as the particle moves from x equals to 0 to x equals to 6m. For the solution, work done equals to area under graph. We will be using the trapezium formula, which is A equals to 1/2 times A plus B times C. So 1/2 times 4 plus 6 times 5, we will get 25 Newton meter.
Energy is defined as the system's ability to do work, and the SI unit for energy is the same to the unit of work, which is J joule, or kgm2 as -2. And energy is scalar quantity. Energy have two kinds of energy. First is kinetic energy, second is potential energy.
Kinetic energy. Kinetic energy is an energy stored in a body in motion. Kinetic energy of a body is the energy possessed by the body because of its mass and bulk. The equation of kinetic energy is K equals to 1/2 mv power of 2. Potential energy. Potential energy is an energy stored in a body or system because of its position, shape, and state. Potential energy can be divided into two, which is gravitational energy and elastic potential energy.
Second one is gravitational potential energy. The definition is energy stored in a body due its position in a gravitational field. The gravitational potential energy depends only on the height of the object above the surface of the earth. The equation of gravitational potential energy is Ug equal mgh, where Ug is gravitational potential energy of the object, and then m is mass of the object, g is acceleration due to gravity, and h is height moved by object.
The next one is elastic potential energy. The definition of elastic potential energy is energy stored in an elastic material or body. The elastic potential energy depends only when it stretched or compressed. Springs are a special instance of device which can store elastic potential energy due to its compression or stretching. The more stretched, the more stored energy. The next one is The equation of elastic potential energy is U small s equals to 1 over 2 kx square equals to 1 over 2 fx, where U small x equals to elastic potential energy J, which is joule, K equals to the next spring constant N per N, X equals to the amount of strength or compress M. Based on the graph of F small s against X, the area under the graph equals to U small s. On the next picture, U small s directly proportional to X. Obeys Hooke's law, F equals to negative Kx, also mean as U small s equals to 1 over 2 F small s X, where U small s equals to elastic potential energy of a spring, joule, F is small s, restoring force of the spring, and X is extension or compression, M. The negative sign in the equation indicates that the direction of F is always opposite to the direction of the amount of strength or compression.
This is 5.2b, Principle of Conservation of Energy. Principle of conservation of energy stated that for an isolated system, energy can be transferred from type to another, but total energy of the system remains constant. According to the principle of conservation of energy, we get sigma initial E equals to sigma final E, or the initial of total energy equals to the final of total energy. Energy can be transferred from one form to another, but it cannot be destroyed or created. In a conservative system, for example, no friction, the total mechanical energy, kinetic plus potential, is constant. These are the application of the principle of conservation of mechanical energy.
For example 5.2.1, the question is a cricket ball is thrown upwards with a kinetic energy of 45 joule. If its mass is 0.156 kg, what is the maximum height can it reach? We're gonna use equation UG equal M times G times H. So UG is 45 joule, M is 0.156 kg, G is 9.81 ms negative 2, and we need to find H. So the solution is 45 equal 0.156 times 9.81 times H. 45 equal 1.53036 times H. So H equal to 45 over 1.53036. So the answer is H equal to 29.4048 meter.
For the example 5.2.2, a ball of mass 0.50 kg is at point A with initial speed u equals to 4 m over s. A head of 10 meter as shown in figure above. Ignore the frictional force. Determine A, the total energy at point A. We use the formula E equals to K plus U equals 1 over 2 mv square plus mgh. We put the information that the question given and we got 53.05 joule. For the example 5.2.2, a ball of mass 0.50 kg is at point A with initial speed u equals to 4 m over s. A head of 10 meter as shown in figure above. Ignore the frictional force. Determine A, the total energy at point A. We use the formula E equals to K plus U equals 1 over 2 mv square plus mgh. we put the information that the question given, and we got 53.05 joule.
Example 5.2.3. A marble is launched vertically upwards by using a spring with spring constant 5.0 Nm -1. Find the compression that must be met to the spring if the marble of mass 5.0 reach a maximum height of 5.0 meter above the marble's initial position on the compressed spring. Okay, first kali kita kena keluarkan maklumat lagi, iaitu mass dia 5.0 gram, tukarkan kepada kilogram, dia 0.005 kilogram. Ketinggian puli tu ke atas ialah 4.0 meter. G iaitu gravity ialah 9.81 ms (Newton). Spring constant dia K iaitu 5.0 Nm (1), dan X kita tak tahu sebab suruh cari compression. Okay, so formula dia kita akan gunakan dua formula, iaitu elastic potential energy, lepas tu gravitational potential energy. Iaitu untuk elastic potential energy ialah US sama dengan 1/2 kx kuasa 2. Gravitational potential energy ialah UG sama dengan mgh. So dalam hal ni dia akan guna dua formula sebab untuk energy before dia kita gunakan elastic potential energy sebab dia daripada kulit tu dia pergi kat bawah, dia nak naik ke atas. Lepas tu baru kita akan gunakan formula gravitational potential energy. So formula dia akan dapat total energy before sama dengan total energy after. So dia akan jadi 1/2 kx kuasa 2 sama dengan mgh. Lepas tu kita masukkan semua maklumat dalam formula tu, dan akhir sekali kita akan dapat compression dia iaitu X ialah 0.28 meter.